Welcome to another episode of the Concrete Logic Podcast. And today I have Kevin Cavanaugh with Arcosa Lightweight. Did I get it? Kevin? Did I say your name right?
That's correct. Yes, sir.
All right. Off to a good start, Kevin. Before we get into the topic today, which is lightweight aggregates, and we're going to talk about how they obviously lightweight concrete, this concrete show. So we're going to talk about concrete, obviously, but Kevin also deals with CMU, lightweight CMU. So we may talk a little bit about that as well. But before we get started, just to remind everybody, the 3 things that you can do for me if you listen to this podcast. I need your help. You can support the show in 3 ways. The first way is share the podcast. Share it with somebody you know, somebody that doesn't listen. Maybe somebody that does listen maybe they didn't listen to the episode and you said, hey, this was a great episode. Make sure you listen to this one. But please make sure you're sharing it. The second thing you can do is if you go to concretelogicpodcast.com, there are a couple ways that you can reach out to me. There's a contact button at the top. And I'm going over there right now. Yeah, it says contact. So click on contact and you can shoot me a message. And what I'm looking for there is a topic or guest suggestion for the show. A majority of the shows that we have are suggestions from either folks that are listening to the show or past guests. So those, those suggestions are very helpful. That way we are putting out episodes that you actually want to hear. And you can also, if you would like, you can leave me a voicemail too. If you're like me, if you like to talk versus writing, I rather talk. That's why I do a podcast. I feel like I'm better at this than I am at the writing part. But anyways, there's a microphone in the bottom right-hand corner. You click on that and it records your voice right over your computer. And it leaves me a voicemail. And again, that's another way you can give me an idea for a guest or a topic. And if you want, when you leave the message, we've had this happen before where someone said, hey, you can play my message on the podcast. So we can do that too, if you'd like. So, and then the last way is in the upper right-hand corner of the homepage. On the website, concretelogicpodcast.com, there's a donate button. If you click on that donate button, you get a couple options on how you can donate to the show. There's a monthly subscription thing. There's a way there you can leave any amount. And that's just a way of you showing that you're listening to the show. You appreciate the show because we don't charge you for what we put out. We give it to you for free, and then you come back and you tell me what it was worth to you. So it's called a value for value model. So there's no paywalls or anything like that, which is very annoying to me, especially on LinkedIn when someone posts something and they'd say, hey, check this out, and you click on it, and then there's a paywall. That's really annoying. We don't have paywalls on Concrete Logic Podcast. So, yeah, so we put out, like today, Kevin's going to share his wisdom with us today, and then you can come back and say, hey, this was how much it was worth. And you can any amount you give is appreciated. So okay, with that, Kevin, Kevin is with Arcosa Lightweight Aggregates. I guess you probably should start with what the heck is lightweight aggregates, and why do concrete folks care about it or should care about it?
Well, first of all, there are many different types of lightweight aggregates. There's natural, volcanic, scoria, pumice, that type of material. From volcanic activity, it's been used for, on and on centuries, actually, starting with the Romans. Parthenon, one of the largest, if not still the largest unsupported dome on the planet. That was volcanic material 2,000 years ago. Modern lightweight aggregates, the type that are used in most concrete applications, other than insulating. There are insulating concrete materials, perlite, vermiculite. There's cellular concretes. It's a lot of air entrained additives to give a very bread, if you know, an analogy to a slice of bread, there's a lot of air bubbles in there. But the materials that we deal with are structural grade ceramic aggregates made in a rotary kiln. The kiln is not the same size and it doesn't burn as high a temperature as a cement kiln, but otherwise it's very similar. I am not a manufacturing expert. I couldn't even tell you how long it takes a material to traverse through the kiln. I'm going to guess it's 25 minutes, something like that maybe. But the modern lightweight aggregates was actually an accidental discovery about 100 years ago, maybe 107 years ago in the 1917 roughly. Clay brick manufacturer in the middle part of the country in Kansas, Stephen Hayde, Hayde, noticed that his clay brick were coming out of his, I don't know what type of, how he fired them, but his end products were having little balls and little knobs of material that was ruining the rectangular prism shape of the clay brick. So he did a little more research, he tinkered, and he just, some folks have said given lemons make lemonade. So he refined what was happening in the kiln. He studied it. And lo and behold, he found a valuable material, ceramic, structural grade, lightweight aggregates. And these are made from either shales, clays, or slate. They all have very similar chemical and mineralogical characteristics. As you can imagine, slate is denser and harder. We sometimes use it in roof shingles. And then you have shale, which is a little bit softer. And then you have clay. And it's really a matter of how long that material's been in the ground and under pressure for however long that deposit's been there. But when they're heated, they all bloat to a degree. This is what was happening to Stephen Hayde's clay in the clay brick. And he patented this, and he received a patent he applied for a patent and received a patent from the federal government and promptly gave that patent to the U.S. government so they could make ships for World War I. There's a shortage of steel. And some of those ships are still in existence today. One of them is the USS Selma. It's in Galveston Bay, Texas. It's in a saltwater environment, serves as a lab where gurus and concrete folks like us can go out and take core samples and look at the condition of the concrete. And then there's another one up on the Powell River in British Columbia that I'm not sure. One of my colleagues actually did a Google search recently, but it still may serve as a dock of some sort or a platform for industry. What's interesting is these concretes.
Sure. I was going to interrupt you, give you a little breather here. And then they have the ones that they're obviously out of commission, but up on the Eastern Shore in Virginia, there's a graveyard of the other ones that they built, which I didn't know till
the same time frame. Yeah, and I think there are also some in just north of the big bridge on the south side of the Beltway in Washington, D.C. I grew up in D.C. area, and there are some sunk in there as well on purpose.
Cool. Yeah. Sorry to interrupt you. Yeah. Keep going.
No, that's fine. But so these ships serve as a way to look at the durability of lightweight concrete over time, and you have to keep in mind these ships were all lightweight material, lightweight fines and coarse lightweight cement, water, etc. Today, it's all coarse aggregate and sand, whereas, and that changed in roughly, I want to say like the 1970s, when the oil embargoes caused the price of fuel to rise. So to make the concrete more economical, we removed one of the ingredients of the lightweight component, the sand, and it's basically coarse aggregate today. But what we discovered, I got to piece together certain different pieces, but the interesting thing is we all know that concrete hydrates forever. Some of these ships, the Powell River ship, it's like 105 pound per cubic foot material. It's like 9,000 psi. today, one of the core samples that I was privy to seeing the data on it, and it was initially 5,000 psi, the mix design. So these ships, and I have a sample of a bridge actually in Richmond, Virginia. I don't know whether that's upside down or not right here. That's the company I used to work for. This was the wearing surface of the nickel bridge, which was replaced in what was built in 1959, and it was replaced when I lived in Richmond and worked for a lightweight aggregate company.
You won't believe this. I lived like 2 miles from that bridge.
Yeah. So there's not a lot of cover over this piece of rebar, and this was actually coated with like a varnish, but the rust you see there is from being exposed to the air. It's not from the penetration of any chlorides or bad materials. But the ships gave insight because they're all lightweight materials, and going back about 30 years ago when all the supplementary cementitious materials came into being used more and more, especially for bridge decks, we wanted to make them very impermeable. We learned that we made them very strong and somewhat brittle, and we had cracking issues occurring, drying, shrinkage, cracking, as well as chemical shrinkage, because we couldn't get enough water to the supplementary cementitious materials. And what we learned from these old samples of concrete from the ships is there's another mechanism occurring, and it goes back to some research in the 50s and 60s. It was internal curing. The lightweight fines distributed throughout the paste and the matrix are small bubbles, if you will, or small sponges that have water that can be available for long-term hydration. So I know I've kind of covered a lot of different territory in the history of modern lightweight aggregate. It was, an accidental discovery by the clay brick maker, and then started to be used in concrete ships because of a shortage of steel. And then why do you use lightweight concrete as a high strength to weight ratio, frankly? I'll give you a chance to maybe absorb some of that and ask me a question, because I did.
Maybe compare a standard weight, normal weight concrete. Like if you were to take I guess compare the I don't want to say specific density. That's going to, maybe people don't have a hard time. If you were to do like a normal slab, like an 8-inch slab, could you compare the weight for a lightweight concrete versus a normal weight concrete or something? Give us kind of a comparison there so we understand why we use lightweight concrete.
Yeah, the density of a concrete at equilibrium for lightweights anywhere between 105 to 120. Common ones are 110 and 115. That's at equilibrium. Whereas normal weight concrete is 145, 140. And so depending on which of those two you're using as the basis, if you're going from the lightweight to the heavyweight, that's 30 pounds extra over 105, 110. That's about 30% more weight. If you go the other way, it's about lighter. 130 divided by 145, it's 20%. Depends which you're using as your basis of comparison.
Right. And we would use lightweight concrete because it'd make the overall structure lighter. So therefore, your foundations could be less substantial compared to a normal weight structure. So there's savings there. Am I going down the right path? What other advantages are there to using lightweight concrete versus normal weight?
Well, the weight is one of them for sure. I mean, you can use smaller steel columns or fewer beams in a building. That's the case of a recently finished project in Chicago, Salesforce Tower. And I believe that was one of the winners of the ACI, competition, and it's going to be presented by the contractor that did the work at the ACI convention in the fall. And right now the name of the contractor is failing me, but I could pull up the case study. But that's number one. The weight reduction allows to less steel. And today, with the focus on carbons, reducing the amount of carbon, embodied carbon in materials, if you have less steel in a building, that's a good thing. If you have lightweight concrete, it allows you to do that. And it's, this is a high-rise building. It was 58 stories. And if it had been normal weight concrete, they would have had to have multiple extra picks of the crane to pick up mostly the beams, or they would have had smaller bay sizes. So there would have been more steel and more picks of the crane. And it actually allowed the job to be completed quicker.
So you don't use sand in the lightweight concrete mixes. Did I hear that right?
We don't use the lightweight fines, the lightweight sand. You do use, pardon me, that's the landline. You do use natural sand, natural fines, coarse lightweight aggregate.
Okay. And
the other big reason in high-rise steel frame metal deck, and this could be a steel frame metal deck building that's 2 or 3 stories, is the fire ratings. If you have a corrugated metal deck, you put lightweight concrete on it, it's 3¼ inches, I believe, versus 4.5 for normal weight concrete to have the 2-hour fire rating. And with a lightweight deck, you actually don't even have to put fireproofing spray underneath on the ceiling side of the floor below. You do have the fireproofing spray in both of these applications on the columns and the beams. But in the case of the lightweight system, you don't have to put it on the bottom side of the corrugated deck. It's a UL fire rating. So that would be probably the big two, is, you have better fire resistance, less concrete to be used to get that same hourly fire rating, which then allows you to have, thinner slabs, which once again helps reduce the amount of steel that's in the building.
Okay. And all right, so those are the benefits. Are there any downsides to using lightweight concrete? I mean, should it be used for every type of job, or is there some jobs where it doesn't make sense to use lightweight concrete?
Well, you're talking to a lightweight concrete guy here. So, but no,
but I mean, we, as a expert in lightweight concrete, or expert in anything, I think customers appreciate where you tell them, hey, this is an ideal project, versus trying to sell them. I'm the same way. I just told an engineer the other day that he shouldn't have designed a steel building. It should have been concrete, and I'm sure he appreciated that comment. But I mean, what are the downsides? I know I have a little bit of experience with lightweight concrete. So one of the things I can think of, and I'm on your Arcosa website, and I'm just reminding myself of some of the nuances of lightweight concrete, and one of them is the special handling of the aggregate. What do you have to make sure to do with the aggregate
you need
versus
to pre-soak
normal weight concrete?
You need to pre-soak the lightweight aggregate, especially if you're going to pump it.
Right. Yeah.
We have
I did a job
and go ahead.
I did a job in Cleveland, and we couldn't figure out why we couldn't pump the lightweight concrete, and I ended up being the guy that went out there and made sure they were soaking the aggregate before it came out to the site.
Was this recently?
Oh no, this is early in my career, long time ago. But so you got to make sure you're soaking the aggregate. Is that just for pumping considerations, or is that just good practice overall?
It's probably good practice, but it's not necessary to make concrete. If you don't pre-soak you're not going to get any type of internal curing from the fines or the coarse material. And again, I didn't explain the internal curing all that much in detail, but you use fines in internal curing because you have more distribution of reservoirs of water versus the larger sizes, the coarse aggregate. But you definitely want to get the material to SSD, saturated surface dry. Earlier in my career, that was flipped around the other way, so I might be saying it backwards, surface dry, saturated. But you can do it with typical garden sprinkler, it's just an oscillating spray head and turn the pile. And if you're going to pump, probably good practice would be to turn the sprinklers off the night before to let the pile reach an equilibrium, and then maybe fold the pile, the morning of, so you don't have pockets that are real wet or pockets that are dry. And you can confirm this by taking a unit weight measurement the morning of the pour. You know what it's supposed to be damp, loose, and you know what it's supposed to be, in a dry state. And you just, if the aggregate production is consistent, those two numbers, and you can adjust the batch. Actually, if you have, if the material is supposed to be 50 pounds a cubic foot and you measure it at 45, there's not enough moisture in there, but you can still batch it. You can still place it. If you're going to pump it, you may have a bit of a problem, but you want it to be at SSD, saturated surface dry. And that's typically depending on the aggregates. And there's multiple producers in the U.S. have expanded shale clays and slates. We all have the similar characteristic where it very quickly in the first half an hour or two, it spikes as it absorbs moisture, and then it kind of levels off over time. The final absorption could be anywhere from 6, 7, 8% up to around 30%, depending on the aggregate type. But those curves, they all match one another. The shape of those curves they're identical pretty much with manufactured expanded shales, clays, and slates.
You're saying the saturation, the lightweight, saturating the water when you're soaking it. Is that what you're saying?
Yeah. When you're sprinkling it so we use the term pre-soak, but it's really, you're not necessarily dumping it into a pit of water. You're going to trap air underneath the aggregate when you dump it in. It's better to do the reverse, where you put it in a pool and then you fill that pool up with water. So the water rises up around it. In the northern climates, a lot of producers do that. Chicago, Minneapolis, they call them soaking pits.
Oh, okay.
And then where it's, extreme cold, up here around in the Great Lakes area where I live in Milwaukee, you can condition the material before winter sets in, and it'll keep that moisture. And you can do projects in the middle of winter. If you're not typically doing a lot of lightweight concrete, it can be a challenge for some ready-mix producers that don't do it regularly, because it's difficult to do that outdoors. You definitely can't sprinkle when it's sub-freezing temperatures.
Right. Yeah, usually you see sprinklers out. That's what I've seen before.
Yeah,
I didn't know they dipped them in vats. Huh.
It's like the size of a swimming pool, depending on the size of the operation, the ready-mix producer.
Oh. What about so that's the internal curing that you're referencing, is that you're soaking the aggregate before, and then the aggregate is slowly releasing the water, and in doing so it's internally curing the concrete.
Yes, exactly. So I didn't fully explain how we got to internal curing in the last couple decades, but it had to do with the bridge deck concrete with the very low permeabilities that were achieved in the lab with the supplementary cementitious materials. But in the field, we were experiencing a lot of cracking in these bridge decks, so we're kind of defeating ourselves. So in order to hydrate that SCMs in there, you had to have an extra source of moisture, which in this case is brought to the concrete by the lightweight aggregate defines, it distributes the water more effectively. A lot of research done. There's an equation that a gentleman at the Bureau of Standards. When I was in college, I was a co-op student in the heat transfer into this lab, and he was down on the concrete. But it's called the Bentz equation, B-E-N-T-Z, and it's 7% by weight of the cement or the cementitious materials. That's the amount of moisture you need to have absorbed within the lightweight aggregate. Or you have to have that amount of water available, and that water is brought into the concrete via the lightweight aggregate. So if it's a mix with, let's do simple math. If I could do this off the top of my head, 500 pounds of cement, 7% of that is 35 pounds of water that you want to have in the aggregate itself. And if you know the water, the aggregate absorbs 10%, you can figure out how many cubic feet, 10%, how many cubic feet of lightweight aggregate you have to have. And it's typically, with the materials that I'm familiar with, it's 2 or 3 cubic feet of material. There are some places, the state of New York, that just said, hey, and what you do with that 2 or 3 cubic feet of material is you take out the natural sand that's not absorptive, it doesn't have water absorbed into it, it has surface water, you replace it with the lightweight fines. The state of New York said, let's just make this simple because we don't want people to go through the math, and just replace, I think it's 30% of the natural sand with lightweight fines. And that covers most of the mixes. Yeah.
Do you find when they use lightweight concrete, are they still curing externally or no?
We have never recommended to eliminate external curing. Some researchers are leaning that direction. I'm not on top of all the most recent research like some of my colleagues that attend the ACI 213 committee meetings and the 308 pavements, but some are moving that direction. There are also some products in the market that call themselves internal cure, but it's not lightweight expanded shell clays or slates that's doing it. It's sort of it's a good name they selected, but I don't know that everyone agrees it's internal curing what's happening.
You're referring to colloidal silica products?
Yeah. I understand they don't give up the water because of an electrical charge. And depending on how fine that colloidal silica particle is, sometimes they're referred to as liquid fly ash, and then other times they call it internal cure, depending on the size of those particles. And I know they've had good performance. I don't want to, besmirch the good performance they've had, but it's slightly different, I believe, from the way internal curing happens as we understand it.
Yeah, I mean, it's different from what you're talking about. Yeah, I didn't. When I saw your note about internal curing, I thought you were going to go somewhere else with it. So yeah, that
where
makes
did
sense.
You think that I was going to take that?
I don't know. I saw your note. I was like, because we've had the internal curing folks on here. So and we've talked about colloidal silica numerous times. And like you said, they've had great success with it. It's seems to be it seems to be one of the remedies out there to deal with the newfangled type 1L cement. Since that cement seems to be water starved, so it's another source for that cement. It seems like. What have you seen? I know you're not totally well versed in everything going on with the concrete side, but have you seen any? I guess here's a question for you. Since the Type 1L transition, have you seen an increase in use of lightweight concrete?
I wouldn't say so, no. I mean, I think mostly what we hear is contractors are pushing back because it finishes differently and it has different characteristics. But no, I have not heard that. I mean, that could potentially be a very easy fix
Mhm.
You mentioned earlier where would lightweight would I not recommend it, and where would I recommend it? But I gave a talk to an engineering firm in Madison, Wisconsin, a few years back, and after I gave them the talk, they said, "Well, we should use internal curing everywhere because it doesn't just address shrinkage; it increases compressive strength. You can make your pavements thinner. Imagine 100 miles of road where you take a half an inch or an inch of pavement out. That accrues to great big benefits, but." That I answered it by saying what was the downside was you do have to make sure the aggregate's preconditioned or pre-soaked. And that's a good question. I will want to pursue that with some of Arcosa's gurus and other folks at 213. The thing is, though, this internal curing water that's in the lightweight aggregate does not come out immediately. And the
Right.
water that's absorbed in the aggregate is not part of the mixed water. You don't have to consider it. It's not part of your water cement ratio.
Oh, huh. I would have thought
Yeah.
the opposite. Like you got to do some math there because don't they do that with sand? Like if you get if
That's
you
surface
bring
water. That's
surface water. Okay.
Yeah.
All right. So
Yeah.
they
There
don't
you do
count
have to consider.
Yeah. So they don't consider the yeah, because how would you do that? I guess you compare the pre-soaked condition to the soaked condition of that to figure that out. I don't know. You said it doesn't count, so I don't even want to try to wrap my head around that. So
Well,
yeah, I'd be curious to see if people are going to that because people are trying to I recently talked to Mike Hernandez. He's the technical director at AESCC, and he's got a survey that they are putting out to all the concrete contractors out there to talk about the issues that they've had with Type 1L cement. But he's more wanting to know which mixed designs out there that folks have been successful with to I guess tackle the challenge of Type 1 cement since it acts differently than what we've been using the Type 1-2 cement. So yeah, I'd be curious to know if you're seeing an increase in that use and folks are using that as a lightweight aggregate as a possible solution to the Type 1L cement performance. You mentioned the pushback from concrete contractors on the lightweight concrete because of the finishing. What are they saying? What is it more difficult to finish lightweight concrete, or it's just different, or?
No, that comment was with the 1L cements. That's what we heard from the local ACI meeting. But I do know that some contractors do worry about finishing lightweight concrete. They a lot of times they want to do no air for some reason, put a hard trowel on it, and you have to wait for the bleed water to come up. Sometimes it's a different timing than what they're used to seeing. So it's just a matter of having pre-pour conferences or job meetings to iron out all these questions. And the lightweight aggregate industry has technical reps that are more than willing to sit down with the ready mix producer and the concrete contractor. And that was basically the thrust of my conversation at the ACI Central Ohio chapter, where you connected, or Ed Gebauer connected the two of us.
Yeah. And make sure you're paying attention to your mix designs when you're bidding a job and checking and making sure you're dealing with normal weight or lightweight concrete, because I'm sure there's guys that overlooked that.
Yeah.
Is there anything else? We're getting close to the end here. Is there anything else you want to discuss today before we end the show? I told you 30 minutes goes quick.
It goes real quick. Yeah, I next time I'm going to organize my thoughts a little bit better, so I have
you did fine.
Yeah, but I there's been a misnomer for years that lightweight concrete causes trouble with floor coverings, and it goes back to 20 years or so ago when the VOC adhesives were they were outlawed or disallowed, whatever. the mechanism was, but a lot of thought came out. Oh, the lightweight aggregate is allowing moisture to seep through, and it's causing a problem with adhesives. And that turns out not to be accurate. I can send follow-up information to you, or maybe we could talk about that in the next installment of this, or I can have one of the other Arcosa folks who's real expert in this and did the research. And I shared that information with the group at the ACI chapter meetings I've been in. I don't have the top of my head right now, but it was not the lightweight aggregate that caused the problem. It makes sense that it would be, because it's an absorptive aggregate, but the research found it was pretty much the same with either type of normal weight or lightweight aggregates.
We've talked about that topic several times.
Like today, it's very humid up here today in Milwaukee, and a lot of has to do with the ambient conditions about how that deck cures initially before you put the and whether the structure's enclosed, whether there's some heating, all that stuff has an impact. So we fought that for a long, long time, and I think we finally got past it. But it's planted in the minds of many engineers and practitioners that it's a challenge. Like the term lightweight, a lot of people think lightweight means not very strong, not durable. And that's not necessarily true. This is a ceramic structural grade material, and it's used in offshore oil structures, in Arctic environments, specifically to resist ice flows. It has better abrasion resistance. So there's some misnomers, like in the concrete block world. There's lightweight, there's medium weight, normal weight. I would like to consider that the heavyweight or the normal weight stuff is ordinary, and the lightweight concrete masonry units or lightweight concrete is extraordinary. It's all nomenclature, and a lot of that nomenclature provides different connotations in people's minds.
So, lightweight means weight, like it's light to pick up, versus
it is
light, not lightweight, like it's weak. So still concrete.
It's still concrete. Yeah,
that's right. Yeah. All right. Well, Kevin, I'd love to have you guys come back on the show. We could talk about lightweight concrete floors and as far as its interface with flooring. We've talked about that before. Definitely could get the lightweight concrete perspective on that. But yeah, it's not the concrete's fault majority of the time. So we can discuss that in the future. Kevin, thank you for coming on the show. And folks, until next time, let's keep it concrete.
Thank you.